Ever wondered how a jet engine can push a plane through the sky with nothing but air and fuel? It's not magic, it's physics. The engine takes in air, compresses it, mixes it with fuel, and burns it all at supersonic speeds. The result? A jet of flame and gas that propels the plane forward. The first step is compression. Air is sucked in and forced into a smaller space, raising its pressure and temperature. This is where the engine's compressor blades do their work, spinning at thousands of revolutions per minute. Once compressed, the air meets fuel in the combustion chamber. The fuel is injected and ignited, creating a rapid expansion of gas that generates massive thrust. This is the heart of the engine's power. The resulting hot gases are then directed through turbine blades, which spin to power the compressor. This cycle repeats, creating a continuous source of thrust that keeps the plane moving forward. And that's just the beginning. From there, the exhaust is expelled at high speed, pushing the engine and the plane forward in the opposite direction. It's a dance of pressure, heat, and motion. So, what exactly are we talking about? Jet propulsion is the process by which a jet engine generates thrust to move an aircraft forward. It's all about pushing air backwards to make the plane go forwards. At its core, jet propulsion relies on Newton's third law. Every action has an equal and opposite reaction. The engine accelerates air, and the reaction pushes the engine and the plane forward. Combustion is where the magic happens. Fuel is injected into the compressed air and ignited, creating a rapid expansion of hot gases that exit the engine at high speed. This high-speed exhaust is what creates the thrust. The faster and more massive the exhaust, the more force is applied to the engine, and the more the plane accelerates. So, in short, jet propulsion is a cycle of intake, compression, combustion, and exhaust, each step contributing to the force that moves the plane through the air. Jet engines power everything from your favorite jet fighter to the planes that fly your luggage. If you've ever flown, you've benefited from the same physics that make rockets work, just at a much more efficient scale. Understanding how a jet engine works helps you appreciate the engineering behind your daily commute, and even the space missions that rely on similar propulsion principles. Even though you might not think about it, jet propulsion is the reason your GPS navigation works, your weather forecasts are accurate, and your global supply chain moves goods efficiently. Knowing how jet engines work also helps you understand the environmental impact of air travel and the innovations that are making it cleaner and more sustainable. So, next time you're on a flight or watching a rocket launch, remember, you're witnessing the same fundamental principles of jet propulsion that engineers have been refining for decades. Back in the 1900s, the jet engine was a radical idea. Engineers like Frank Whittle and Hans von Ohain independently conceptualized using exhaust gases to push the aircraft forward, not propellers. The first working jet engine was built in 1937 by Whittle, and it powered the Gloster E-28-39, the first aircraft to fly solely on jet power. It was a simple but groundbreaking design. The Cold War accelerated jet engine development, with the US and Soviet Union racing to build more powerful and efficient engines. This led to the introduction of afterburners and turbofans. Today, jet engines are found in everything from commercial airliners to military jets and even spacecraft. The same basic principle of jet propulsion has evolved into a marvel of engineering. Imagine you're holding a balloon filled with air. When you let go, the air rushes out and pushes the balloon forward. That's how a jet engine works, but with super hot gas instead of air. Inside the engine, fuel mixes with air and burns super hot. This makes a super fast stream of gas that pushes the engine and the plane forward like a rocket. The engine is like a big fan, but instead of blowing air, it's blowing fire. The fire pushes the engine backwards, which makes the plane go forward. So, the jet engine works by using fire to push the plane. It's like a big, powerful fan that turns heat into motion. Before the engine can produce thrust, it needs a fuel supply and an intake for air. The fuel is stored in a high-pressure tank, and the air is drawn in through a large, smooth intake at the front of the engine. The intake is designed to slow down the incoming air and direct it efficiently into the compressor. This ensures the air is compressed and ready for the combustion process. Once in the engine, the air is compressed by a series of rotating blades called compressors. These compressors increase the air pressure, making it more dense and ready for fuel injection. The compressed air is then directed into the combustion chamber, where fuel is injected and ignited. This creates a high-energy gas that will be used to produce thrust. Each part of the engine is carefully engineered to handle extreme temperatures and pressures, ensuring the system operates safely and efficiently from the very first step. Now, the air is compressed by the compressor, which is a series of rotating and stationary blades that slow down the air, increasing its pressure. This high-pressure air then enters the combustion chamber, where fuel is injected and ignited to create a high-energy gas stream. This hot gas then moves into the turbine section, where it expands and turns the turbine blades, which are connected to the compressor. As the turbine spins, it drives the compressor, creating a continuous cycle that powers the engine and produces thrust. Now, the air is compressed and heated, but the real magic happens when it's twisted. This is where the turbine comes into play. The high-energy gas flows through the turbine, which is a series of rotating blades that convert that energy into mechanical work. These turbine blades are engineered with precision, using advanced alloys to withstand extreme temperatures and forces. They're not just spinning, they're doing work to drive the compressor at the front of the engine. As the turbine spins, it turns a shaft connected to the compressor, which is the heart of the engine's breathing system. This is a clever twist because it creates a self-sustaining cycle. The turbine drives the compressor, and the compressor feeds the turbine. This interaction is what allows the jet engine to keep running without needing an external power source. The energy from the hot gas is being harnessed to power the engine itself, making it both efficient and powerful. This clever twist, where the engine powers itself, makes the jet engine a marvel of engineering. It's a perfect balance of force, motion, and control, all happening inside the engine's core. At the heart of jet propulsion lies the gas turbine cycle, a process that converts fuel into high-speed exhaust, creating thrust through Newton's third law. The compressor, made of rotating blades, compresses incoming air, increasing its pressure and temperature before it enters the combustion chamber. The turbine, connected to the compressor, uses the energy from the expanding gases to spin and drive the compressor, creating a continuous cycle. Finally, the exhaust nozzle accelerates the hot gases, converting thermal energy into kinetic energy, which propels the aircraft forward. Imagine you're in a car, but instead of pressing the gas pedal, you're blowing air into the back of the car. The air pushes against the car, pushing it forward. That's the basic idea of jet propulsion. You push air backward and you get thrust forward. Now, instead of a fan, think of the jet engine as a powerful engine that takes in air, compresses it, mixes it with fuel, and then burns it to create high-speed exhaust. That exhaust is the force that propels the jet forward. It's like a giant fan, but with a lot more power and precision. The engine acts like a giant pump, forcing air out the back, and that's how you get the force to move a plane through the sky. So even though it sounds silly to compare a jet engine to a car with a fan, it's actually a very accurate analogy. You push air back, and you get pushed forward. That's the magic of jet propulsion. Jet engines are like high-tech fans on steroids. They take in air, compress it, burn it, and spit it out with enough force to move a massive aircraft. It's the same principle, just on a much larger and more intense scale. Before you go, if you enjoyed this, please give it a like and subscribe so you don't miss the next one. And tell us in the comments what you'd like us to make next. We read every single one. Thank you so much for watching. Comment this emoji if you made it to the end.